1. Oh, I didn't see you there. So you're probably asking yourself what I'm doing here. That's a good question. But just stay with me here. I'll explain myself. So as you can see, we have a projectile launcher aimed at a target hanging from the ceiling. But watch what happens when the ball is launched the same time that the target is released from rest.
Science!
In 3, 2, 1.
Cool, right? I mean, to understand what's happening here, let's break it into parts.
Let's set up two frames of the launch of which to look at, the initial and the final. Basically, as the projectile is launched from the launcher, it has a certain y velocity and a certain x velocity. As a side note, velocity is the change in displacement over time, while acceleration is the change in velocity over time. As soon as the ball is launched, the target is dropped from the ceiling. In two-dimensional motion, an object's x velocity is unchanged as it travels through the air. This is because there is no acceleration in the x direction. However, there is an acceleration in the y direction due to gravity. The main idea applied to this experiment is the concept that an object falls with the same acceleration no matter what, if we disregard air resistance. According to the equation, yf equals yi plus v0yt plus 1/2 gt squared, where yf is the final y height reached by the projectile, v0y is the speed of the projectile as it leaves the gun, g is the gravity constant, and t is time, the projectile and target will have the same y final in time. This is because the 1/2 gt squared part of the equation determines the loss of displacement of both the target and the projectile as they fall. As the projectile gains y displacement, the target loses y displacement. However, the impact between the two can only occur if the projectile is aimed at the launcher. The same principle can be applied to an Evel Knievel fanatic motorcycling over a pool of alligators.
I know this can be a bit overwhelming, so let's simplify this a bit. Let's say that the initial velocity in the y direction of the projectile is 0. And let's add another ball, which we can drop from rest at the same height, and see what happens. Oh, wow, that was perfect.
Basically, the same principle from the previous experiment is applied here as well. By analyzing these two experiments, we can understand there is an independent nature about the velocities in the x and y direction. The y velocity, these both rely on the acceleration due to gravity, while the x velocity doesn't experience an acceleration. This shows that they travel the same y displacement in the same time. So as a final experimental procedure, we will use the same setup as the first time, but this time we will decrease the initial velocity and we will point the projectile higher than where the target is located. Will it make an impact?
Whoa, we don't want to give away the answer just yet, but we will accept video responses. We'll show the correct answer next week. Until then, thanks for watching.